Okay, in this video we're going to introduce the idea of the modulus and the argument of a complex number z. So if we start with the complex number z equals to x plus iy, we have already seen that we can plot this on the Argand diagram, and it's going to be represented by the point xy. Okay, so this distance is x here. This is the real axis, this is the imaginary axis, and this distance is y here. Then that is going to be our complex number there. Okay, now the undirected distance from the origin to the point xy, so from the origin to the point xy is actually called the modulus of z. Okay, so this is called the modulus of the complex number z, and it is denoted as follows. So we can write mod z. We can also write z with these absolute value lines, or we denoted r. So that is this distance here. Okay, so that's the modulus. Undirected here means that that distance is always going to be positive. So because directed is like the distance to the right is positive, distance to the left is negative. So those are directed distances. Distance upwards is positive, downwards is negative. Those are directed. So if it's undirected, we're just saying what is the length of this distance without referring to whether we're going upwards, downwards, left or right. So it's always going to be positive. Now by Pythagoras here, then we can see that mod z, which is also denoted r, is going to be the square root of x squared plus y squared. So that is by Pythagoras. Then next there is this angle here, which we are going to denote theta. So so the angle made by the terminal side through x with the positive real axis is called the argument of z. Okay, so and it's denoted arg z. We also use theta to denote that one. So that one is the argument of z, and it is the angle made by the terminal side through xy. So terminal side through xy with the positive x-axis, with the positive x-axis or real axis. Okay, that's the same thing. Okay, so that is going to be this angle here. Of course, the convention is that counterclockwise is positive and clockwise is negative. So that's the same convention from trigonometry. So what's going to happen then is, in terms of formulas, argument z is going to be the inverse tangent of y over x if our complex number is in the first quadrant or in the fourth quadrant. Okay, so that's quadrant 1 or quadrant 4. If we're in quadrant 2, then there's going to be the angle of 180 is going to come in. So in terms of radians, so then it's going to be given by that. So this is in quadrant 3 or quadrant 2. But when it comes to the calculations, we will work through these step by step. We'll take you through the step-by-step calculation, so that you don't have to necessarily cram these without understanding. All right, so let's look at some examples now. Can we find the modulus of a complex number z? Can we find the argument as well? All right, so here we're given some complex numbers. For each one of them, we want to find the modulus, not modus. Here, modulus. By the way, plural of modulus is moduli. So one modulus, two moduli. And then also going to find the argument theta for each complex number. Now, the main thing that we're going to note here is that we want to make a sketch always. If you do these and you don't make a sketch, you significantly reduce your chances of getting them correct. So always make a sketch. So for the first one, in A, we've got z equal minus 2 plus 2i. What I want to do here is we're going to say, well, what is x here? And x is the component without I. So x is negative 2. What is y? The imaginary part is 2. So we're talking the point negative 2, 2. This point is in quadrant number 2. So we're going to make a sketch. So the complex number we're dealing with is going to be something somewhere there. This side is negative 2 and this side is 2. So r is going to be that distance there. So simply r is going to be negative 2 all squared plus 2 squared. Then we take the square root of that. It's going to be 4 plus 4 is square root 8. So this is 2 root 2. So that is going to be our modulus. Then the argument is going to be this angle here, okay, theta. So the first thing I want to do is always here we need to work out inverse tangent y over x. So in our case, inverse tangent y is negative 2. Y is positive 2 and x is negative 2. So this is inverse tangent negative 1. So let's see what happens if we punch that in the calculator. I'm going to be working in degrees, then we'll later transform to radians. So inverse tangent there, then -1. Okay, so this gives us -45. Okay, now clearly we've got an angle in the second quadrant. Those angles are between 90 and 180, so that cannot be correct. But what is actually happening is when we punch that in the calculator, the angle that we got is this one here, which is always going to be the case. So that is telling us that is -45, which means theta is going to be that plus 180, or 180 minus 45. So that is where that formula that we did earlier comes from. So in this case, we're going to have 180 plus inverse tangent minus 1, which we've just calculated to be -45. So this is 135 in radians. That is going to be 3 pi over 4. Okay, then for B, we've got z equal 1 minus I root 3. Then again, question is, what is x here? And x is 1. What is y? Y is -√3. So this is a complex number in quadrant number 4. Okay, so we're going to have this situation. This is 1, this is -√3. So that means the modulus simply going to be 1 squared plus -3 squared. Then we take the square root. It's going to be 1 plus 3. This is going to be square root 4. So the modulus is 2. Then for the argument, we can either do the argument like this, in which case it's going to be negative, or we can do the argument like that. Either will be acceptable. So according to our formula in quadrant 4, we can just do inverse tangent y over x. So let's see what that gives us. So inverse tangent y is -√3, x is 1. So this is simply inverse tangent -√3. So if I just go back to this one and plug in √3 there, so this gives us -60. So -60, which is clearly this one, because we said clockwise is negative. So -60 in radians is minus pi on 3. So remember, for converting to radians to degrees, 180 degrees is equals to pi radians. Okay, so but if we wanted to express it like that, which is equally correct, okay, so this would be 300 degrees, which we can then write in terms of radians is going to be 5 pi over 3 this time. Okay, then for C, we've got z equal to -3i. In terms of coordinates, the x coordinate is 0, the y coordinate is -3. So this one is going to be located on the vertical axis below the origin, 3 steps away. So that's where this complex number is going to be. So this distance here is going to be 3, and which from that straight away, this is going to be by inspection. It tells us that r is 3. And then the argument, we can do it this way. Again, by inspection, that's just going to be 270, which is 3 pi on 2. Or if we do it this way, that's going to be negative 90, which is going to be negative pi on 2. This is all by inspection, just from your sketch. In fact, you're going to discover that if you try and do these using the formula is going to crash, because tangent is not defined when x is 90 or its odd multiples. So here you would have, for instance, negative 3 over 0, and then if you try to do this in the calculator, you are going to have a problem, because negative 3 over 0 is infinity. So this just emphasizes the importance of the sketch. So the sketch is really going to be helpful sometimes, even when the formulas crash. Okay, for D, we have got z equals to negative 2 root 3 minus 2i. So this time the x is negative 2 root 3, the y is negative 2. So this is a complex number in the third quadrant. So we're going to have this situation, negative 2 root 3 here, negative 2 here. So again, then we can do theta this way or that way. But let's start with r. So r is going to be negative 2 root 3 squared plus negative 2 squared. Then we take the square root of that. Negative 2 root 3 is going to be 4 times 3. So that's going to be 12. Then that one is going to be 4. So this is going to be square root 16. So the modulus is going to be 4. Then for the argument, we're going to have 180 plus inverse tangent. So when you say y over x, this is what we're going to get. So this is 180 degrees inverse tangent 1 over root 3. Then if we plug in inverse tangent 1 over root 3 here, so just modify this 1 divided by root 3, that gives us 30 degrees. So this is plus 30 degrees. So this is 210 degrees. 210 is 7 pi over 6 in radians. But if we want to read it this way, then that's simply going to be negative 150. Negative 150, which is going to be negative 5 pi over 6. All right. At this point, we're going to give you a chance to have a go at the last 3. So you can just pause the video and have a go at these ones. And then when you continue the video, you can compare with our answers. All right, we're now going to scroll down to our solutions. At this point, we'd like to thank you for visiting our channel and watching this video. We hope that it is useful. Please do not forget to subscribe. If you've got any questions, I would like to hear from you. Just post them in the comment section. Please do, of course, like the video and share accordingly. In E, we have got 1 plus I, so the corresponding coordinates are 1, 1, so we're in the first quadrant. We've got a triangle here with 1 and 1, so that means the radial distance is going to be root 2. If this is 1, 1, this is isosceles, so that means the theta is going to be 45, or pound 4 again, so just by inspection. For the second one, we've got -5, which corresponds to the coordinates, point with coordinates -5, 0. So this distance from here to there is 5, so that means r is 5. This angle, again by inspection, is 180, which is pi, but you can do the same angle that way, so that means this is plus or minus. Okay. For g, we've got -x and +y, so in the second quadrant. Then if you plug this into the formula, r is 1, and for theta, this is going to be 180 minus 30, so that's that. All right, thank you.